The other part that I'm going to expect you guys to do tomorrow on the quiz that isn't here yet is comparing distributions of quantitative variables. So what happens when you have two separate distributions? How do you make those comparisons? So what I did is I changed this to, we've been looking at the to school data, how long it takes me to get to school. And that had a min of 7, quartile of 7.625. And this is just me remembering because I did this a gajillion times because there's 4 sections, right? And for this one, this variable is essentially my commute time, right? So the time it takes me to get home, same distance and everything, okay, is a similar variable, but it is distinctly different at the same time. Okay, so if I want to make a comparison of those two groups, well, I'm going to go ahead and I put all the times for me to get home. All right, so knowing that, can we find that 5-number summary? What's the minimum? The maximum? 10.5. There's 13 of them, guys, so where's the median? It'd be the 7th one, so 9. Remember that Q1 is just the median of those first 6, which is halfway between 8.25 and 8.5. So 8.375. Yeah?
Since that one are kind of estimating, will there be multiple answers or set?
No, because you're not estimating. You're doing 8.25 plus 8.5 divided by 2. Q3? 9.875. And again, that one is the median of just these 6. You're going halfway in between. But we're in our notes packet right now. All right, and just looking at these, is anything jumping out at you?
Their average a little longer, across the whole.
Say that again?
I think average their longer times.
Okay, so more specifically, it took longer to get home than it took to get here. Yeah? Are we comfortable with that? Yeah. Okay. Anybody want to guess as to why? Because remember, we're always thinking about what is the story that might tell. You think the traffic is different at 7 versus 3? Yeah, probably. There's a little bit more cars on the road at 3 o'clock. Guys, these are all times where I drove here. How do you think that might change, knowing I come from High Street-ish area on my bike?
20 minutes.
I tell you what, the times to get here are up by about 8. The times to get home are about the same. Anybody want to think about why on that?
You want to get home?
Huh?
You want to get home?
Not at all. I'm exhausted on the way home. How many of you have ever walked or run 3rd Avenue?
Oh, it's uphill.
It's very uphill. Like 3rd Avenue is uphill. You don't notice it because it's like a really long, shallow grade. But I can tell you by the time I hit Grandview Avenue, there's profanity going on the inside of my head about that stupid, stupid hill that I hate. It's the worst. All right. So, I might ask you to make comparisons of the same variable for two different groups, right? So this is the same variable, commute time, for two different groups of times, okay? And if I do that, one of the things we want to use to do that is to look at some parallel graphs. So we're actually going to start with the parallel dot plot. So in all a parallel graph is it's both groups graphed on the same axis, but like above each other, like parallel to each other. So to make my parallel dot plot, I'm still going to go make an axis that goes from 7, 8, 9, 10, 11, and 12. We're going to have commute times on the bottom. And let's go ahead and do to home on the bottom here. Okay, and then I'm just going to make a dot plot of just those. So 7.75, 8.25, 8.25, 8.5.
May I have your attention, please? Seniors E through L, please come to the media center through the front doors for pictures. Thank you.
What's up? Good morning. He's getting his picture taken, but I'll give it to him.
Okay, yeah, because he could come after class. Whenever it's convenient for you, after class is fine.
Okay. All right, so what are some things we see when we... So by putting these on the same axis, it makes it a little bit easier for us to make those direct comparisons. So do these graphs support the idea that it took me longer to get home than to get to school? I think so, with the exception of that one outlier, right? Okay. And talk to me about, like, so when we describe graphs, there were like 3 things I wanted you to describe: the shape, the center, and the spread. Talk to me about the spread.
It's not as big as the school.
The to school graph seems to have more variability than the from school graph. Is everybody with me? Right on. Okay. All right. Now, parallel box plot, guys, is very, very similar. Except for it's just going to be box plots instead of. Now, theoretically, we should be checking for outliers in the time it takes me to get home. Do you guys, are there any outliers there? I don't think so either. Okay. So we can just kind of plot, there's my 7.75, my quartiles. We do the same thing. A reminder, this went out, we made the whisker to 9.75. Because you don't connect to outliers. What do you guys think?
Box plots.
Do you guys see that the box plots are, with the exception of the outlier, the box plots are practically the same? And I would at least listen to, though, I would listen to an argument that both groups have similar variability, like that. So like when we look at a box plot, the IQR, which is a measure, so we kind of have three different measures of spread that we talked about. We have the range, the IQR, and the standard deviation. Okay, these are all different ones that we've talked about different times. Okay, and when we look at the IQR, we can see it on the box plot by looking at this distance from here to here, because that's essentially the distance between the quartiles. And when we look at this, the IQR for these is practically the same. In fact, numerically, I think it is the same. Okay? And likewise, even like if I ignore that outlier, the range is pretty much the same. Like you can see the range on this graph is the distance from here to here if we ignore that outlier. It's the distance between the tips of the two whiskers. Okay? And so as we look at that, like both of these to me seem to have very similar spread with the exception of that outlier. And so when I ask you to write a few sentences comparing distributions, okay? You know, before we compare two distributions, you're just going to compare what those values are. Okay? So if I asked you using those dot plots to compare them, and I say, hey, how do the shapes compare? And you can even do a bulleted list like this that you know you're supposed to do shape and center and spread. Okay? And I would probably say something like both the commute times both to school are both unimodal or both mound shaped. Because they really kind of are. Like if you look at this kind of general, in that sense, they're kind of the same. But to school had one high outlier.
May I have your attentions, please? Seniors M through R. Seniors M through R to the Media Center.
Now, when comparing two graphs, and we're trying to make a comparison about the center of those two graphs, okay, that comparison needs to use the word than in some way, okay? Now, what are the two measures of center we can use to describe that we've been using so far?
Mean and median.
The mean and the median. Given what we have right now, I might use the median because we've already calculated it. But we could estimate the mean of that second group, okay? So when we do this, so our measures of center are the mean or the median. I'm writing this up there because it caused some issues yesterday of what do I mean by describing the shape, the center, and the spread. So if I'm just describing a distribution, I just say the median is approximately this, or the mean is approximately this. If I'm comparing two different groups, that's when I might say the median commute time to school is lower than the median time from school to home. And if I wanted to be really specific, I might say something along the lines of 8.125 is smaller than 9. You got your makeup off.
Yeah. I did not want to wear the black lipstick.
I'm keeping this on my face all day.
Yeah.
Okay. Last thing. Okay. So for the spread, if you wanted to say there was more variability in times going to school than going home, because to school had a higher range, that would be good. If you wanted to say they had similar amounts of variability, that would be because the IQRs are identical, because they both have an IQR of about 1.5 minutes, that would also be fine. But really, that's all we have to do. So if you just, now here's what kids do that always makes the graders mad, okay? And they lose points for this, and it's so dumb. They say, oh, the median commute time to school was 8.125, and the median commute time from school is 9. And they never they don't actually make that direct comparison. Saying the two numbers is not the same thing as making that conclusion that one was smaller than the other, right? The big idea is it takes me less time to get to school. And if you're not strictly saying that less time, that than word, then you're not actually making a comparison. You're just stating two facts about each thing instead of directly comparing them to each other. And that's how the College Board reads it. Okay, so you really have to, in fact, if you just had this statement, you'd probably get full credit, though certainly I would add the numerical support for it, okay? But you definitely need to have all the details there, okay? How are we feeling? All right, so from here, I'd like you guys to work on the review that I passed out, okay? You would like that. You have a quiz tomorrow that is directly on that review, okay? All I did was change the contexts and the numbers around. All right. Once that review probably is not going to take you an hour. And you have an hour. Okay? Once you're done with that review, I want you working on AP Classroom. Everybody good? Right on.
Keep that up for a second.
Yeah, and I'm